Fusion Mobile, quality e-learning experience on the go.
You're welcome back to today's clinic. The topic for today is captioned trigonometric ratios. When we talk about trigonometric ratios, we talk about areas of the sides of a triangle. Okay, that is they are the ratios of the lengths, ratios of lengths of the sides of a triangle, a right angle triangle for that matter, a right angle triangle. Okay, so we'll make some illustrations given the triangle below. Alright, we have this triangle. Okay, and then this is the hypotenuse side, okay, which is the longest side, and this is the adjacent side, and this is called the opposite side, which is the side opposite the hypotenuse side. And if I should denote the triangle as triangle A, B, and C, okay. There are three trigonometric ratios you can derive from this triangle, okay, and the three trigonometric ratios that we can derive from this triangle okay are the sine, the cosine, and the tangents. Okay, they are formed using the lengths of the three sides of the triangle. Right, and we said they are the sine, or the one denoted as sin, and then okay, and then we have the cosine. The one denoted as cos, and the tangent, shortly denoted as tan. Okay, and hence for the triangle given above, I think we need to repeat the diagram of the triangle. Okay, if this were to be our triangle, alright, and then this is our hypotenuse, this is our adjacent, and this is the opposite side, the side opposite the hypotenuse, triangle ABC. Alright, these are the properties we have for the lengths of the triangle. The sine is given to be equal to the opposite side all over the hypotenuse side. Okay, and from this triangle, you know, the sides that face the opposite side is B, small letter B. The side that faces the hypotenuse side, the side that faces the opposite side is a small letter C, and then the side that faces the adjacent side is a small letter A. Okay, you use the angles where that fixes them. Okay, you see C faces the opposite side and B angle faces the hypotenuse side, so that's how they are denoted. Okay, so you can simply say that opposite side, okay, is C over the hypotenuse side, which is B. All right, and then the cosine is given as the adjacent side divided by the hypotenuse. Okay, you can as well look at the diagram, use the side adjacent A over the hypotenuse B. All right, and then the tangent is given as the opposite side, okay, all over the adjacent side, okay, which is equal to the opposite side there is A over C. All right, and then the adjacent side, the opposite side there is C, sorry, okay, and then the opposite side there is A. All right, so we say opposite C over the adjacent side A. Okay, and so that takes us to the next slide, where we have some other relationships, 1 over sine. All right, so when we write off these signs, you can see that we are talking about the signs of angles, okay, and the angles are the place where you have the arrows, okay, and this place is called angle A. You know, the angle that stays with A you can call angle A, and the angle that stays with B you can call angle B, and the angle that stays with C you can call angle C. So this as well can be written as to be equal to sine of angle A, and this can be written as cos of angle A, and this can be written as tan of angle A, you know, provided that you are just given one angle. Okay, you can call the angle A, or sometimes you see the angles being denoted as theta, and then theta, and then theta. Okay, but when we go into illustrations, you will understand better. All right, there are inverse relationship between the three ratios. 1 over sine theta, okay, let me simply use theta so that I don't confuse you, is equal to 1 over the ratio of theta, which is opposite over hypotenuse, okay, which is as good as saying taking the inverse of it, which is hypotenuse over opposite, okay, which changes the value from A over B to B over A. Okay, we've taken the inverse, and it is called cosecant of theta, or shortly denoted as cosec theta, and then 1 over cos theta, which is as good as saying inverting the original relationship, that is hypotenuse of adjacent becomes adjacent all over hypotenuse, okay, which is equal to C over B, which is also called the secant of theta, or denoted as sec theta. All right, and then 1 over tan theta is given as opposite over adjacent, but this time around it inverts and it becomes adjacent all over opposite, which we had before as C over A, and it changes now to A over C. Okay, it is called the cotangent of theta, which can as well be written as cotan or cot theta. Alright, so having these ratios, you can determine any relationship between the sides of a triangle. But you should note that trigonometric ratios can be used to determine either the missing sides, can be used to determine missing sides of a triangle, or the missing angles, missing sides of triangles, or the missing angles, okay. And it is used provided that a side of a triangle and at least one angle and at least one angle is given. Alright, so when you have this, you can easily find the missing side of the triangle. We shall make illustrations using the following example. The first example I have there is example 1. Okay, we are told to determine the missing side of the triangle below. The missing sides of the diagram. Okay, there's a triangle there. Triangle below. Okay, and you are given this triangle. Alright, this triangle A, B, and C, and then D and E. Don't mind the lines, they are used to denote straight lines. D is given as 60 meters, A is given as 2 meters, and you're told to find the missing sides of the triangle. Solution: the missing sides here, missing sides are AB and BC, because by looking at the diagram you find out that AC is equal to DE, okay, which is equal to 60 meters. Okay, that means AC2 is 60 meters, and so we shall apply trigonometry. Okay, you find out that there is no angle given here, and which will make it difficult to determine, so we can put an angle 28 degrees and then we continue with our work. So solution, just like I've said, note that AC is equal to 60 meters, and it is because AC is equal to DE. Okay, and since we have a side, and the side we have there is AC, and an angle that is 28 degree. Okay, so we can easily determine the missing sides. Okay, you can determine the missing sides AB and AC. Okay, therefore determining the missing side AB relative to, with reference to AC, which is equal to 60 meters, and the angle of 28 degrees, okay, as given there. So remember that we are looking for three factors now. We are looking for, we have three components. We have the side AB, the one we are looking for, and then we have AC, the side we already have that can help us find AB, and then we have the angle of 28 degrees. Okay, and so we're looking at AB and AC. AB is the hypotenuse side, and AC is the adjacent side. Okay, we shall look for the relationship that combines the hypotenuse and the adjacent. Okay, and then the relationship that combines the hypotenuse and the adjacent side is relationship number 2. Okay, you see, all this relationship we've stated can simply be summarized with the word called SOHCAHTOA. Okay, where this stands for the first relationship, this stands for the second relationship, and then this stands for the third relationship, because it is easier for you to determine the relationship that holds between two using this simple formula, okay, than trying to remember what it implies here, because here states that so means that opposite over hypotenuse, which is for sine, and x stands for sine theta, and then ka means cos, adjacent over hypotenuse, and then toa means tan, opposite over adjacent. I think it's simple to be remembered this way, all right, than the other one. So if we try to apply that here, we have SOHCAHTOA, okay, where so stands for opposite and hypotenuse, and the two sides we have a hypotenuse and adjacent, so this can't work. And then we have ka meaning adjacent of a hypotenuse, okay, and then the two we have here is hypotenuse and adjacent, so it means that rule number 2 can work. And so we can say therefore cos of 28 degree is equal to adjacent. The adjacent side is AC, and then the hypotenuse side is AB. Okay, good. So you can as well denote as the adjacent side AC 60 meters over AB. We don't know the value of AB yet, and so we can say that cos of 28 degrees is equal to 60 meters over the side AB. So you can say AB multiplying both sides, AB cos 28 degrees is equal to 60 meters, so that AB itself will be equal to 60 meters all over cos of 28 degrees. Okay, I just believe you understood the computation so far, and which can be written as 60 meters all over cos of 28 degrees. If you punch on your calculator, you have 0.8829. okay, and then if you divide out, you will be having 67.9542. okay, so therefore you can say that AB is equal to 67, and further truncation gives us 67.95, or we can truncate further to give 68 meters. So the side AB is equal to 68 meters. Okay, go ahead to find the other side, assuming we intend to find the other side, BC. If we intend to find side BC, okay, if we intend to find side BC, okay, given the side AC. All right, so we'll solve as follow. Just given the side AC and the angle of 28 degrees. Okay, we'll solve as follow. Alright, you have to remember that BC side is an opposite side, and then AC side is an adjacent side. Okay, so you have these two properties, O and A, and then you check your SOHCAHTOA to find the sides. O and H, no. A and H, no. O and A, yes, this can work. And so we can say therefore tan of 28 degrees is equal to opposite of adjacent, which is equal to the opposite side there is BC, and the adjacent side there is AC, which is equal to BC, which is BC over AC is sorry, let me go back. AC is 60 meters. Alright, AC is 60 meters, and so we can carry out our computations as follows. You can say therefore tan of 28 degrees is equal to BC over 60 meters, which implies that 60 meters tan 28 degrees is equal to BC. Alright, and which is as good as saying 60 times tan 28 is given as 0.5317 equal to BC. And so when you multiply these two, you have 31.9026 to be equal to BC, which can approximately write as therefore BC is equal to 32 meters. Alright, so we can go back to our triangle and denote BC as 32 meters. These are the methods you can use to find the missing sides. Sometimes you might be demanded to find the missing angles. Sometimes you might be demanded to find the missing angles, and maybe you are asked the following question. Let's take that as our example 2. Okay, maybe you are told that if sine theta is equal to 4/5. Okay, rather, sorry, if sine theta, let's take it the other way, not 4, not 5, assuming sine theta is equal to 5/4. Okay, find theta. Maybe you are asked to find theta given that theta is 5/4. Alright, the way you do this is this. You can start by fixing a triangle. You can start by fixing a triangle. Okay, good. And maybe you denote this point as theta. We don't know what it is. I will know that sine theta is defined as opposite of a hypotenuse. Fine. Alright, sometimes you may be asked to find the mixing angles, assuming you are given, for example, say our example 2, assuming you are given that sine theta is equal to 4/5, and you're told to find the value of theta. Good. And all you have to do is the solution to 2. Remember that sine theta is defined as opposite of a hypotenuse. Okay, which implies that 4 is the opposite side of the triangle and 5 is the hypotenuse side. Alright, so you can continue by saying this. So you make an imaginary triangle, okay, having in mind the following sides, that the opposite side is 4 and the hypotenuse side is 5. Okay, good. And so you can continue this way, 4 over 5, and then you can say 4 sine theta. Alright, so for you to continue to find theta, you take the sine inverse. Okay, to find theta, you take sine inverse. Taking sine inverse is as good as trying to divide out. And so trying to divide out, you have to divide out sine so that theta could become the subject of formula. Okay, so that sine can cancel out on this part, and then you have theta to be equal to 4 over 5 divided by sine theta, divided by sine, which is as good as saying 4 over 5 times 1 over sine. Okay, now remember 1 over sine you can write in your index form as sine inverse, okay, of 4 over 5. Alright, so without wasting time, you can use your calculator to determine what the sine inverse is. So what is the decimal ratio of 4 divided by 5? Okay, what we are talking about here is the sine inverse of 0.8. okay, so if you want to do this computation using your calculator, you can quickly go to your calculator, press on the shift button, and then press on the sine key, and then introduce a bracket, then put the digits 0.8, okay, and then strike the equality sign key, and it gives you that sine inverse of 0.8 is 58.1301, okay, which is also truncated to be equal to 58 degrees. Alright, so the sine of angle theta, which we are looking for, okay, is theta is equal to 58 degrees, equal to theta. Alright, so there are several questions that could be asked using this, but these are the basic ideas you need to resolve questions of this form. Have a nice day. Bye.